Hello friends, welcome to the presentation on successive differentiation. I am Dr.Rajeshree. In our today's presentation, we'll see the nth derivatives of standard function and then the Leibniz theorem. First of all, definition and notation we'll see. Definition: let y is equals to f of x be a function of x differentiable on an interval I. The derivative of f is denoted by f dash of x. Thus, f dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h if limit exists. If the function f dash x is also differentiable, then it gives the second derivative of f of x denoted by f double dash of x. Thus, f double dash x is equals to limit h tends to 0 f dash of x plus h minus f dash x upon h if limit exists. The process can be continued and we get the nth derivative of f of x if the required limit exists, and it is denoted by f in x. Now we'll see the notation part. The successive derivatives are also denoted by y dash x, y double dash x, so on, yn x, or y1x, y2x up to yn x, or dy by dx, d square y by dx square, and continue dny by dxn. Now we'll start with the derivatives of substandard functions. So first of all, let us take y equal to x raised to m for small m belongs to capital N. This y1 is equals to m into x raised to m minus 1. So it is the first derivative. y2 is m into m minus 1 into x raised to m minus 2, and so on. yn is equals to m into m minus 1 up to m minus n plus 1 into x raised to m minus n. Thus, ym is equals to m factorial and yn is 0 if n is strictly greater than n. Next is, if y is equals to ax plus b raised to m, then yn is m into m minus 1 up to m minus n plus 1 into a raised to n into ax plus b raised to m minus n. Thus, yn is equals to m factorial upon m minus n factorial a raised to n into x plus b raised to m minus n for small m belongs to capital N. Thus yn we can write as m factorial into a raised to m, and yn is 0 if n is strictly greater than m. Next is, if y is equals to a raised to mx, then y1 is m into a raised to mx into log a. y2 is m square a raised to mx into log a square, and thus we'll get yn is equals to m raised to n a raised to mx log a raised to n. The special case is here, if a is e, then the above function that becomes y equal to e raised to mx, and thus yn is equals to m raised to n e raised to mx. Next function we'll take is y equal to 1 upon x plus b. So it can be written as x plus b raised to minus 1. So let us see the first derivative. y1 is equals to minus 1 into a into x plus b raised to minus 2. This y2 is minus 1 into minus 2 into x plus b raised to minus 3. And continuing so on, we'll get yn is equals to minus 1 into minus 2 up to minus n into a raised to n into x plus b raised to minus n minus 1. So it can be written as minus 1 raised to n factorial a raised to n divided by x plus b raised to n plus 1. Next is, if y is equals to log ax plus b, then y1 is 1 upon x plus b into a, that is a upon x plus b. Put n is equals to n minus 1 in the above nth derivative, we'll get yn is equals to a into the bracket minus 1 raised to n minus 1 into n minus 1 factorial into a raised to n minus 1 upon x plus b raised to n minus 1 plus 1. So it is in fact minus 1 raised to n minus 1 n minus 1 factorial a raised to n upon x plus b raised to n. Next function we'll take is y is equals to ax plus b. Here we are using the formula cos theta is equals to sine pi by 2 plus theta. So consider the function y equal to x plus b. Now y1 will be a into cos ax plus b. By using the above formula, it can be written as a into sine ax plus b plus pi by 2. The next is y2, which is equals to a square cos x plus b plus pi by 2, which is written as a square. Here instead of cos it should be sin x plus b plus 2 pi by 2. Then in general we have yn is equals to a raised to n sin x plus b plus n pi by 2. Similarly, we can find out for function y is equals to x plus b, we have to use the formula cos theta plus pi by 2 is minus of sin theta. And for function y equal to cos x plus b, we have y1 is equals to minus a cos x plus b, which is equals to a cos x plus b plus pi by 2. Then similarly continuing, y2 is equals to minus a square sin x plus b plus pi by 2, which can be written as a square cos x plus b plus 2 pi by 2. And similarly we'll get the nth derivative yn is equals to a raised to n cos x plus b plus n pi by 2. So next and the important function we'll take is y is equals to e raised to x sin bx plus c. Here y1 is equals to, we'll use uv formula here. So it is equals to a into e raised to x sin bx plus c plus e raised to x cos bx plus c into b. So it is written as, it is equals to e raised to x into the bracket a sin bx plus c plus b into cos bx plus c. Put a is equals to r cos theta and b equal to r sin theta. Therefore r is equals to under root a square plus b square and theta is tan inverse b upon a. So here we'll get y1 is equals to e raised to x r cos theta sin bx plus c plus r sin theta cos bx plus c, and it is equals to, it will take r common, it is r into e raised to x sin bx plus c into cos theta plus sin theta into cos bx plus c. So it is the formula of sin bx plus c plus theta. So y1 is in fact r into e raised to x sin bx plus c plus theta. Similarly the second derivative and the nth derivative we can write as r raised to n e raised to x sin bx plus c plus n theta, with r is equal to square root of a square plus b square and theta is tan inverse of b upon a. Similarly we can find out for the standard function y is equals to e raised to x cos bx plus c. So here we have in the similar manner the nth derivative is r raised to n e raised to x cos bx plus c plus n theta, with r is equal to under root a square plus b square and theta is equals to tan inverse b upon a. Yn is a square plus b square raised to n by 2 e raised to x cos bx plus c plus n tan inverse of b upon a. So this was about those nth derivatives of some standard function, and this is the end of our presentation. Thank you. Thanks a lot.